Right, got the old S2 paper, 2014 regional paper, the old international papers, binomial hypothesis testing. Before Roger will use a tennis ball, he checks it using a bounce test. So he bounces all his balls to make sure they all work. The problem that he can do a ball from Roger's usual supplier fails the bounce test is 0.2. 20% of his current balls fail. A new supplier claims that probably one of their balls failing is less than 0.2, so they think their balls are better. Roger checks a random sample of 40 balls from the new supplier and finds that 3 balls fail the bounce test. Stating hypotheses clearly, use a 5% level of significance to test the new supplier's claim. Okay, right, so here we go. So we're going to use a binomial distribution with n is 40 because we picked 40 balls, and initially we're going to assume let's say they're the same. So the new balls, 20% of them fail as well. Now I've got my spreadsheet up. I've got all the individual probabilities down here from 0 to 16. So the chance that if 20% of their balls fail, the probability that none of them fail the test is this. That's really 0.8 to the power of 40. Because if they all pass, probably each one passing is 0.8. So that's so the probability that they all pass, that none fail, is 0.8 to the power of 40. Here are the cumulative probabilities. So that's the same. And then if I add this one to this one, I get this one, and then this one, add this one, gives you this one. The cumulative probabilities. And I've drawn a graph of the individual probabilities here. Can you see the 8's in the middle? Because you'd expect to get about 8, because it's 20% of 40. The chance of that happening is about 0.155. So that's the tallest one. You can get these values, the cumulative ones, which is what we want. Menu 7. Pick a list out, stick in 0 to 5, and then put n is 40, p is 0.2, and it gives you these values, because that's all we're bothered about at the moment. Now, if you look at the cumulative probabilities, look at these two here. This one is less than 5%, and then the next one, probably less than equal to 4, is greater than 5%. That means that our critical region is 0 to 3. We want to find an area, sort of a range of values, where if we go into that range of values, we think, no, we don't want to be there. And so if our range of values, the chance of us going in there is less than 5%, we think, with this 0.2, I'm not too sure about this, because we would expect to get about 8 or 7, maybe even 6, might get 9 or 10. We wouldn't expect to get 0 or 1, because 20% of them fail, and if none of them fail, then we think maybe 20% aren't failing after all. But here's the critical region, and so say if we go into there, then we think that 0.2. Not sure about that. So the critical region is less than or equal to 3. 3 is called the critical value, and that's our cut-off point. So should he change the balls he plays with? Well, it looks like he should, because we're in the critical region. We got 3 balls fail the bounce test. Only 3, when we expect to get about 8 or 7 maybe, or 9. We wouldn't expect 0, 1 or 2, and not even 3, because 0 to 3, the chance of that happening is less than 5%. We don't do individual probabilities. We don't look at these individual ones with hypothesis testing, because it might be, if n is really big, that all the probabilities are quite low. So we look for a range of values where we think the chance of that happening is too small. These values are too weird for us to accept that the p is actually 0.2. What you write in the actual exam, H0, p is equal to 0.2. That's the null hypothesis. That's basically saying the new balls are no better than the old balls. H1 is p is less than 0.2. So the new supplier is saying the chance of their balls failing is less than 0.2. That's called the alternative hypothesis, of course. We're using a binomial 40 0.2, and we assume to start off with that H0 is true, and see if what we found out does fit in with what we're assuming. but the chance of getting 3 or less is lower than 0.05, our significance level. So we think, it is significant. We're going to reject H0, and that yes, the supplier is looks like the supplier's right. The product ball found bounce test is less than 0.2.